Welcome to the NITRD Podcast, where we explore the cutting-edge advancements and collaborative efforts shaping the future of networking and information technology. For those of you that don't know, NITRD stands for the Networking and Information Technology Research and Development Program. Join us as we connect with leading experts, discuss the latest trends, and uncover how NITRD is driving technological progress across the nation. Stay tuned as we embark on this journey through the forefront of technology, innovation, and research.
Welcome to the first episode of the podcast series on artificial intelligence. My name is Faisal Dsouza, and I will be the moderator for this episode. The Artificial Intelligence Research and Development Interagency Working Group coordinates federal AI R&D and supports activities tasked by both the National Science and Technology Council's Select Committee on AI and the Subcommittee on Machine Learning and Artificial Intelligence. This vital work promotes U.S. leadership and global competitiveness in AI and its applications. The AI IWG reports investments to the AI R&D program component areas. You can view this investment figures on the NITRD dashboard by visiting the NITRD website, www.nitrd.gov. We have several agencies that help make this AI Interagency Working Group successful. 3 joining us today are the Department of Energy Office of Science, the National Science Foundation, and the National Institutes of Standard and Technology. As the NITRD AI Technical Coordinator, I am pleased to introduce our AI Interagency Working Group co-chairs, Dr. Stephen Lee, Dr. Michael Littman, and Dr. John Garofolo. Welcome to all 3 of you. To kick things off, what is AI and why is it essential? I'll start with Michael.
Hi, everybody. I'm Michael Littman. I'm the Division Director for Information and Intelligence Systems at the National Science Foundation. I'm on rotation from Brown University, where I'm a professor of computer science, and I study machine learning, artificial intelligence, and reinforcement learning specifically. One of the reasons that I think artificial intelligence is so important is because, like computing, it's about automation. It's about taking tasks that we would like solved as human beings and not having to do the tasks, right? Being able to delegate those tasks to machines to carry out on our behalf. So they can do tasks for us that we don't have the energy to carry out. We don't have the speed to carry out. We don't have the scale or the scope to carry out. And so that's actually a really, really powerful thing when computers can act on our behalf and do the things that we want. So one of the things that we have to pay very close attention to, of course, is to the extent that we're delegating tasks to computers, we have to be very, very sure that they're carrying out our wishes in the way that we actually want them carried out. And I think that's one of the big challenges that a lot of people are grappling with in the context of artificial intelligence systems, particularly that we're building in novel ways using large amounts of data and creating potentially very, very complicated systems. And ultimately, it's hard to wrap our heads around exactly what these systems are doing. So I think there's lots of really interesting topics from a research perspective. And certainly in my role at the National Science Foundation, it's about trying to support the research community in exploring these issues.
Thank you, Michael. I'd like to ask Steve Lee the same question.
Yes, thank you. My name is Stephen Lee. I'm with the Department of Energy in the Office of Science. I'm a program manager in applied mathematics for advanced scientific computing research. What is AI is a great question. AI is many things. I think Michael alluded to that. But primarily we see AI as an enabling technology for scientific discovery and innovation. Within the Office of Science, AI is becoming a tool for executing the DOE mission. It builds on our strengths with access to massive amounts of scientific data from our scientific user facilities. It builds on our high-performance computing capabilities. And we have such challenging missions in physics and materials and chemistry and in fusion and other areas. So basically, AI, again, is an enabling technology that really helps us to make advances across all areas of science and energy and national security.
Thank you, Steve. And now, John Garofolo. What is AI and why is it essential?
Hi, I'm John Garofolo with the National Institute of Standards and Technology. I'm a senior advisor for advanced analytic technologies. My focus has been on the development of test and measurement research for machine learning systems. I think both of the answers that we heard were fantastic. It's hard for me to add to those. There have been so many discussions around how to define AI. It's almost undefinable and almost in the eye of the beholder. But I will say a couple of themes that keep emerging around definition is that it's adaptable to the needs of the task. And often the needs of the task are related to the needs of a human user. And so I think that adaptation aspect is really important. And then there's sort of two branches of AI, one off in the machine learning area where it's focused on processing input, producing output that is useful for solving a task. And the other is this AGI area, which is very different, which is focused on creating sentient AI, which has innate intelligence. So they're really two different things that we should make sure we talk about them differently.
Thank you so much, John. In our AI working group, we focus on 9 strategic priorities as listed in the National AI R&D Strategic Plan 2023 update. We will touch on some of the following topics throughout this AI series. For our listeners, I wanted to list them out for you. The first strategic priority is make long-term investments in fundamental and responsible AI research. Strategic priority number 2 is develop effective methods for human-AI collaboration. Number 3, understand and address the ethical, legal, and societal implications of AI. Number 4, ensure the safety and security of AI systems. Very important. Number 5, develop shared public data sets and environments for AI training and testing. Number 6, measure and evaluate AI systems through standards and benchmarks. 7, better understand the national AI R&D workforce needs and improve opportunities for R&D workforce development to strategically foster AI-ready workforce in America. Strategic priority number 8, expand public-private partnerships to accelerate advances in AI. And finally, strategic priority number 9 is to establish a principled and coordinated approach to international collaboration in AI research. The federal government plays a critical role in advancing AI, including through smart investments in research and development that promote responsible innovation and advance solutions to the challenge that other sectors will not address on their own. From your perspectives, how do long-term investment in AI contribute to maintaining the United States leadership in fundamental research?
Yeah, so as an artificial intelligence researcher, I think about the notion of long-term investments all the time, right? We're always trying to think ahead of the curve to figure out what's coming, what new capabilities we can unlock, and how we can take the discoveries that have already been made and try to make sense out of them scientifically, try to really wrap our heads around what they mean. And so from that perspective, I think that it's just absolutely essential that we continue to explore this topic. It's one that the more we understand, the more we discover there is to understand, which I guess could be an argument for not doing any more research because we're just going to reveal more things that we don't know. But of course, that's not the right answer at all. The reason that it's revealing more and more questions, the more that we dive into it, is because it's one of these technologies that is sort of foundational. You can build things on top of it. And so each time a new discovery is made, it not only provides a fabric, a support for the problems that we're trying to solve, but opens up the possibility of solving a whole bunch of new problems. And so really the only way to stay on top of this, even apart from trying to stay ahead of the rest of the world, just to be able to apply these ideas for our own purposes, we have to be constantly pushing the boundaries of what's possible and how it gets done.
So a little bit of another angle to what Michael just beautifully said is that we're in a incredibly shifting era right now of the workforce and the amount of effort and funds that are being put in to AI by the private industry. And so there's been a shift from government leading research to industry leading research, where federal investment really helps us focusing on a couple of things, problems that are really important for the American people and for government agencies, problems that they need to solve where they need horsepower of AI. And the other is to identify gap areas that are long-term needs that we can look ahead of where industry and academia is right now and identify some really hard problems that we can help to begin to plant the seeds of focus for the future in those communities on. And so we play a little bit of leading role in that very advanced research, which industry and academia wouldn't take on immediately.
Thank you, John. Steve.
Yes, great question. AI is such a terrific driver for R&D in a number of other different areas. The building blocks of AI come from mathematics and computing and statistics, and building up new areas of research and making advances in those directions that support greater AI capabilities is increasingly important. And then the greater AI capabilities, at least in terms of science, AI can be used for extracting insights from massive amounts of data. AI can be combined with traditional modeling and simulation techniques combined with physics to enable more predictive, more realistic simulations of critical events. And AI being used as a source of automation for scientific experiments and just accelerating and improving the entire scientific method so that we can make societal advances in a number of different directions is extremely important. So I see that as some of the key points about the need for long-term investments in AI for there's so many other things and building blocks that it enables for us.
Can you provide an overview of what AI research and development entails within the federal context? Let's start with John.
So I think that the development of AI in the federal context basically requires the same thing that it requires in industry or academic context. It requires an understanding of the problem, an understanding of the context of the use of the tool that's needed, the development of data to support that need, and ultimately metrics to help understand how well the tool is performing. And that's sort of the development cycle. And then it iterates. And so the government tries to assist in providing some fundamental measurement tools that help industry and academia work with those stages of the problem. And also in terms of how to transition the technology from very basic research through the stages of commercialization and standardization.
Thank you, John. Michael?
So AI research in the federal context. So one of the things that could mean is, why is the federal government investing in AI at all? And that's, I think, the same reason that the federal government invests in all branches of science and technology, to try to keep our country at the forefront of development and be engaged at the highest level in terms of innovation. But then there's also really interesting questions about, to what extent can AI research impact the way that the federal government does business, like that actually gets the work done that the federal government is trying to do, which is in many ways a completely separate question, right? So there's, for example, there's funding of things like material sciences, and then there's government buildings that are built out of materials. And so those are related. But what's really interesting, I think, to me about AI is that the distance between fundamental research about just trying to understand this technology that we have academics doing across the country, and the act of actually applying these ideas to try to solve real world problems, for example, in government, is very, very small. That is to say, a new idea could come out next week where, oh my gosh, this gives us a new way of analyzing investment data, for example. And then in principle, that could instantly be used in all sorts of contexts within the federal government. And so when the federal government is investing in AI research for just the process of understanding these things in the first place, they're also setting the stage for being able to really use these to solve problems within the federal government itself, right? It's a giant bureaucracy that is solving some very difficult information processing challenges. So to the extent that these tools can help with that, that's really powerful. And so there's some very healthy conversations happening between the people who are trying to operationalize the use of AI to solve problems in government and the researchers who are developing these ideas from the depths of their creative souls. These conversations are really important.
Steve, would you like to add?
Sure, I can add a few points in the sense that the U.S. is a clear leader in commercial AI. You hear such names as Google and Meta and other companies. But there is a need for non-commercial AI research, basic R&D research. And I think federal agencies can help push things in the more basic R&D direction, which is one reason we have the Interagency Working Group and the National Strategic Plan. So I think there's a clear role for the federal agencies to play with developing the AI, not for recommending music or dating applications, but for what do we need as a society and what do we need as a nation, and how can federal agencies help to advance that?
Yeah, and just to kind of riff on Stephen's point a little bit, I think that the academic AI community is actually quite well, okay, back in the day, the academic AI community didn't know about anything. I mean, they knew about the AI that they were doing, but they didn't really know about what uses it might be put to. And over time, it became clear that the big tech companies had real uses that they needed, and they did a great job of letting the academic community know what they cared about. And the academic community rose to the challenge and started to focus on problems, really deep, interesting intellectual problems that had direct connection to what industry needed. What we haven't seen as much of is engagement between, say, federal agencies and other kinds of nonprofits and the research community, so that the research community can understand what kind of challenges they face. Because I know there's deep, interesting problems that the academic community could really sink their teeth into and make all sorts of wonderful discoveries that be useful. But that conversation isn't very mature yet. I would love to see more engagement, I think, between academics and agencies.
I'd like to add to that AI is now becoming part of every discipline, every scientific discipline. So not only are we working to develop the core capabilities of AI itself, but we're working to look at how to best integrate it into science in general. And that's a whole other area that's very related. There's feedback, there's connection there. But as Michael said, it's really important to get all of the stakeholders in the room to talk about these very interdisciplinary problems that AI is right in the middle.
Very cool. That just brings me to my next question is how does the federal government collaborate with industry and academia in AI R&D initiatives? Maybe you can share how each one of your agencies are going about these collaborations with academia and industry, if there are such partnerships, and maybe point out one or two.
Yes, this is a very, very important question about how we go about collaborating with others to build out these capabilities. One of the areas that's really getting people excited are these large language models. They've been trained on the internet and have absorbed and ingested tons and tons of data, and they have billions or trillions of parameters. Recently, the DOE established what they're calling the Trillion Parameter Consortium. The acronym is TPC. And that is looking at international collaborations that bring together the Department of Energy National Laboratories, academic and research institute partners, industry and technology companies interested in building, training, and using large-scale language models. So the consortium seeks to pair AI developers and users with TPC members who are building and operating large-scale computing centers. So this is a consortium among various different groups. There's a website for it, tpc.dev. That's just one example of a mechanism for building up these collaborations in areas of crucial interest to a lot of different organizations.
For those interested in contributing to or learning about the TPC, go to tpc.dev. Okay, so our question at the table was, how does the federal government collaborate with industry and academia in the AI R&D initiatives? I'll turn over to John Garofolo.
Thanks, Faisal. So if I talk about my own agency at NIST, there are so many different ways in which we collaborate with industry and academia. We have the conventional mechanisms like contracts and grants. Contracts are focused on specific problems to be solved. Grants support fundamental, more expansive research. But we also have special communities of interest focused on developing metrics for AI problem areas, challenge problems, evaluations, and even prize challenges in some of these areas. And we develop a relationship with industry in multiple facets. One is through MOUs and CRADAs, in which we actually work closely together on a particular problem space. The other is where we build consortia, like we've created the AI Safety Consortium to bring stakeholders together to talk about how do we make AI safe? What would we need to do to ensure safety? And we also develop centers of excellence at NIST focused on particular spaces where those centers also bring together multidisciplinary teams of folks working on the really hard problems in AI. And finally, the standards arena is where it sort of all ends up, where all of the research, all of this multidisciplinary, multidimensional research comes together to develop the basis for regulations, which are so important for society and commerce.
So the National Science Foundation thinks it's extremely important to engage with industry in terms of research and academic pursuits, and does so in a whole bunch of different ways. So one that I would note is, just at a very high level, it's worth pointing out that the NSF supports students and other researchers who generate ideas used by industry, and also industry often hires them and benefits from their training. So that's kind of a human resource / idea transmission that NSF tries to facilitate. In addition, more directly, NSF partners with industry and other agencies like Steve's agency and John's agency to try to create new solicitations, new funding opportunities, and makes them available to academics. So sometimes that means industry helping to kind of scope out what would make a good research solicitation. Sometimes they will help provide money. So some of that money is coming from the federal government. Some of it is coming from industrial partners. But ultimately, we work together to try to have a successful program where new and important research comes out. A phrase that I've learned or have learned to appreciate more since coming to NSF is pre-competitive. And that means to the extent that industries actually have their own proprietary information that they don't want to share and they don't want it to be part of the research process. Okay. But there are lots of really fundamental ideas that are before they're competing that they need to have established. And they are often very interested in making sure that those ideas are supported. And so that's another way. I'd like to point out also that just one that's really struck me as being kind of an amazing combination of academics and government and industry coming together is in terms of the NAIR pilot. This is the National AI Research Resource, which is envisioned as being an opportunity for academic researchers to have access to the compute and data and software and training necessary to really compete at the top levels in terms of AI research. This doesn't exist yet, but there's a pilot that NSF has been asked to help lead that has come together, and the NAIR pilot group has solicited, I think, 2 or 3 dozen different companies, all the top high-tech firms, but also a bunch of others that you may or may not have heard of that are actually engaged really deeply with AI research, have provided various kinds of in-kind contributions, either access to computing clusters or software or even consulting services to really help get AI researchers across the country up to speed and doing their best work. And then finally, I'll mention that a bunch of agencies now have other organizations, sort of partner organizations that are trying to bridge the gap between publicly funded projects and privately funded projects. And so you see things in, for example, NIH has ARPA-H, Advanced Research Project Agency related to health. There's an intelligence version of that. There's an energy version of that, ARPA-E. At NSF, that organization is actually within NSF. It's not a separate organization, but it's called TIP, Technology, Innovation, and Partnerships. And they're in charge of doing things like running something that's called the SBIR program, or sometimes called the Nation Seed Fund. It's basically helping new companies form around interesting scientific ideas and making that transition to practice. And so there's just, there's a whole lot of different ways that the federal government and our 3 agencies in particular are working really closely with folks in industry, both to help the folks in industry and to benefit from what the folks in industry have done to move the academic research process forward.
Thank you, Michael, and John and Steve. I think it's very interesting and fascinating to know the different and various ways the government's working in funding fundamental AI research and development and its partnerships, and for folks to connect and learn. Michael, you mentioned the National Artificial Intelligence Research Resource, the NAIR pilot that NSF is leading, which is mind-blowing with the amount of contributions from industry partners and government partners. Could you share a website link so folks can connect and learn more about the NAIR pilot?
Sure. I will magically wave my hand and it will be in the show notes.
Fantastic. Thank you so much, Michael, for sharing that. You mentioned the various efforts your agencies are leading. I would like to, if possible, ask each of you to provide 2 examples, no priority order, of how your agency is moving the needle in AI R&D.
Let me give 2 examples, but we've actually combined them into one project. So first is a recognition that the AI is trained on what we call multimodal data. It could be text, it could be images, it could be other sources of information. And often this data is not all residing at a central location. So there may be data repositories that are spread around geographically, distributed data. And one area where we're pushing the needle is this idea of federated learning, being able to learn across distributed multimodal data sets as if they were all located in one central location and trained in that way. So this idea of a network of AI machine learning training going on such that you have sort of one coherent, consistent global model that represents all the data that's reflected across all those distributed sites is very important. When you have these things like these large language models like ChatGPT, you cannot assume that you have all the data in one place. So if you can sort of develop and improve these technologies so that you can get the equivalent of a centralized approach. That is very important research direction, given the massive amount of data that is out there. The second direction is related to privacy preserving or privacy sensitive data sets. So some of those data sets, they may be medical records, they may be financial records, things that are confidential in some sense that you want to provide some measure of protection that if you're training on this data, then the overall model cannot be tricked or hacked into spilling the beans on whose information this is, for example. So we have these approaches that talk about privacy preserving federated learning. There's one project coming out of Argonne National Laboratory that is working on such an approach in collaboration with some medical data that's coming out of the National Institutes of Health. So we're really excited to see how that comes forward. And it can be used not only for the NIH example, but potentially used for other applications as well.
Thank you so much, Steve. Privacy is important, and it's gratifying to know that the federal government is working towards these technologies to advance or enhance privacy related to AI. John?
Thanks, Faisal. So NIST is engaged in so many different types of programs that are developing novel research for AI. And I'm trying to think about how to express it on kind of an in-out way. So we're working on the fundamental science of AI, and that's looking at how models are created. How do you test models? For instance, with generative AI, how do you evaluate what's happening inside the model? So we're looking down all the way down at that level in AI, but we're also looking at how do these models exist in the world with users? And we've created a new program called ARIA, which is looking at the socio-technical aspects of the use of AI in the context of a user community and a system. And a system where systems can include people and organizations. And then we're looking at the application of AI out in the world and the regulation of AI through the lens of standards. And so we're performing measurement and research at all of these different levels, bringing it together, flowing up from fundamental research in areas to standards. An example of an area of standards that we're developing is in the area of cybersecurity. So developing standards so that industry can implement technology that can help ensure the protection of our computer systems from attacks by AI, and also to best leverage AI in the use of cybersecurity.
That's absolutely fantastic. Thank you, John. Michael?
If I had to pick two things, I would pick, which I guess I do have to pick two things, the National AI Research Institutes and other specific programs. So let me unpack that a little bit. So the National AI Research Institutes, or the AI Institutes, were kicked off a couple of years ago, maybe 5 years ago, and have been funded in a series of waves. There are now 25 institutes that are being funded, and we've got 4 more that are expected to come online subsequent to the Artificial Intelligence Executive Order that came out this past October. And each of the institutes is selected to advance fundamental and use-inspired artificial intelligence. There's 25 of them. And so it would be probably boring for me to list all of them for you. But in terms of kind of thematic areas, there's a bunch that are related to artificial intelligence to support education. There's a bunch that are connected with artificial intelligence to support various aspects of agriculture. And a lot of these are funded either jointly or entirely by the Department of Agriculture. There's several institutes that are focused on the applications of AI within computing itself, and also to various sciences like material sciences and astronomy and fundamental particle interactions in physics that I can't say that I actually understand, but I do appreciate that people do this kind of research. And it turns out that artificial intelligence is a really powerful way of analyzing that kind of data. And the kind of people who do that sort of research have really deep insights into how artificial intelligence itself can be developed further to be able to support those kinds of applications. And then finally, we have several institutes that are around the topic of trustworthy artificial intelligence. How do we build these systems in ways that give us the trust and the assurance that they actually perform the way that we want them to perform? Our main institute that is in that area is actually joint with NIST, so John's organization. That one's one of our newest ones. We don't know exactly what they're going to be up to, but there's a lot of excitement around what they should be able to do. So it's such an interesting and important topic. The second thing I would mention, I guess I mentioned 25 things already, but I will mention one additional thing, which are several specific programs that focus on aspects of artificial intelligence that appear to require some special attention. So my division at NSF has been around for, I don't know, 30 years or so. And each year funds about 500 different research projects. So there's tons of interesting AI research that are going on. But occasionally we want to call attention to some specific topics. For example, the question of fairness in artificial intelligence systems is something that has people fairly worked up. And as we, as a society, apply these ideas in societal facing applications, this is a real concern. It's something that we have to pay very close attention to. So we funded a bunch of researchers to look into topics around that. And one program that is just finishing up its second round of funding decisions is called Safe Learning Enabled Systems, which is focused on a question that comes up very much when you're talking about building and deploying AI systems, which is how do you make sure that they actually are safe for whatever definition of safe you want to adopt? And we insist that the people who are actually applying for funding for this specify very concretely what it is that they mean by safe and how they can guarantee that a system is safe. This is something that's important no matter what you're building in the world. Any kind of engineered system needs to be safe. But what's super special about these AI systems is that they are learning enabled. So not only does this complicated, weird system have to be safe when you deploy it, but it needs to continue to be safe, even though it's changing its behavior based on the new data that comes in. And that's a challenge that people just haven't had to deal with. Like bridge designers have thought long and hard about how to make bridges safe, but bridges don't spontaneously reconfigure themselves depending on traffic conditions. And so the fact that we now have these systems that are very malleable in that way and are responsive to the data that comes in, it adds some real deep new challenges.
Thank you so much, Michael. All three of you have made a very good case of why AI is essential and why the federal agencies should be involved in AI R&D. Very quickly, could each of you share what more is needed?
There's a lot of concern. I hate to keep picking on large language models, but about the type of data that it's trained on, that it's taking in a lot of information that is out in the public domain, but is copyrighted material as well. So that the artists and creators of material, their work is being used as part of these systems without their permission. So there's one challenge. Michael mentioned fairness. And along with that, I would say, the reliability and the interpretability of the results that they provide is an open question. It can be an important question in many cases. So exactly how it arrives at its decision or the outcome is not at all clear if you try to read through how did it go from the data it was trained on to the outcome that was provided. And overall, I think we all realize that AI is a disruptive technology. So whatever it is we can do to better prepare for both its opportunities and its risks is going to be very important.
I really want to expand on what Stephen just said because it's so important. I think one of the biggest challenges for the government and for industry and academia is to understand how to get inside the black box statistical systems that are created, which are the underlying cores for AI. It's very challenging to be able to understand what's happening, but also to adjust the performance of these systems. And the way it's done right now requires massive retraining and tuning, and it all becomes a bit opaque. And so bringing transparency to what actually AI is created from and how it works is so important. Also, understanding how it works in the world is really important. So when we take these systems out into the world and we use them, how are they changing the world? How are they changing us? Starting to develop a broader societal ethos around the integration of AI is extremely important. And then, we are only at the beginning of our game. Even though we've been running really fast on the creation of these technologies, we're still really, really early on in creating technologies that can work on the order of the human mind. And so there's a lot of basic research that's still to be done to create technology that is really, really robust and accurate and reliable. As Stephen said, reliability and trustworthiness is really the name of the game.
So in terms of what more is needed, I think it's actually interesting to reflect back. If you sat in on the machine learning class that I did 10 years ago, you would hear about all these different ideas that are very much what is happening right now. And you might ask yourself, why weren't we talking about these things then? Like, why was this sort of a niche topic 10 years ago, and now it's everywhere? You can't walk out of your house without somebody engaging you in a conversation about AI. At least that's been my experience. So what is it that makes this moment special? And I think there are two things. One is the implications of scale. So what if we take these algorithms that we've actually had access to for 20, 30, 40, even longer numbers of years and apply them at the trillion parameter scale? This is something that we couldn't really do before. And it turns out some very interesting things happen when you're looking at these systems at that scale. And so what more is needed in that dimension is more access to high-powered computational resources. This is something that Steve's organization, the Department of Energy, is actually very, very well positioned to help support the community in, because they've been doing these sorts of large-scale computing exercises for many, 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 many years. Now, they've been applied to different topics. It hasn't really been about AI in the past, but this is exactly what AI needs right now. So there's a very natural partnership with the Department of Energy. The other topic that I think makes this moment special is that these ideas are starting to actually work well enough that it's worth putting them into the real world. And that means we now have to care about the socio-technical boundary. We have to care about what happens when you put these things into the real world. What impact do they have on people? And so there's a lot to be done there. But I think one of the things that is a really nice start is John's organization, NIST, put together an artificial intelligence risk management framework that very much provides kind of a set of guidelines for how to think about taking these systems that are being built and designed and putting them into the real world and making sure they're okay, making sure that the risks that are raised by doing this kind of application are tolerable and are managed. And so I think it's not an accident that the three co-chairs of the AI R&D Interagency Working Group are NIST, the Department of Energy, and the National Science Foundation, because we're each bringing something extremely important to the table in terms of what's needed as we move forward.
I'd like to expand on what Michael just said, because I think he was really getting to an incredible point. Yeah, we have this incredible relationship between our agencies and how we're performing the different perspectives, the aspects of development of AI and pushing it out into the world and considering its impact. The multiplicative power of all of the agencies coming together to work together under the umbrella of NITRD, it allows us to do what we couldn't possibly do individually. And it allows us to put a lot of really good heads together on hard problems. I think we're at the very maybe end or middle of a great experiment. So back in the 1980s, when I started my adventures in AI, we were looking at how we could create speech recognition systems that could work as well as a human. And we started to study, what if we create language models that have more and more training data, more input? And we saw an increase in performance. Well, we've just conducted the most incredible AI experiment in the world with large language models by pulling in every bit of data that was open in the world that we could. And the big experiment, I think, was, will this approach automatically create human-level intelligence? And in some ways, what we're seeing coming out of these tools that are developed from these large language models are sometimes behave like humans and sometimes they don't at all. So I think this is like a great learning moment. Okay, we might not be able to auto-generate intelligence from data. And what are our next steps now that we've looked at it in this way?
I will just add to that. I think we're all on a learning curve here, especially, we're thinking in terms of building an AI system. But when you start to get into systems of systems where AI models are building on other AI models and other systems, then that's a wild card, right? There's this coming wave of AI technologies and advances, and it's anticipated to affect all aspects of society. And I don't think any of us have a real crystal ball on how that's going to go.
Thank you very much for your insights. Through our conversation today, it is evidently clear why AI is essential. Its transformative potential spans across industries, enhancing efficiency, fostering innovation, and driving unprecedented advancements. As we look to the future, it is crucial to recognize the collaborative efforts that propel this technology forward. I want to echo John's remark on the multiplicative power of all agencies working together through NITRD's coordination. By combining our expertise and resources, we can ensure AI develops in a way that maximizes benefits for society while addressing ethical and practical challenges. Thank you for tuning in, and let's continue to explore the boundless possibilities AI offers in the next episode of the AI Series podcast.
Thanks for listening. Please subscribe to our podcast so you never miss an episode. Visit our website at NITRD, NITRD.gov for more information and additional resources.